Hi, AP Psych. These are your Module 1.5b notes, sleep stages and theories. Our learning targets for today are explain how the sleep-wake cycle affects behavior and mental processes throughout the day and night. So the sleep-wake cycle is a circadian rhythm, which in humans is about a 24-hour cycle. Jet lag and shift work are disruptions of the circadian rhythm. The stages of sleep are identified by their specific EEG patterns, i.e., your brainwave patterns. NREM sleep occurs in stages 1 through 3 and decreases in duration throughout the cycle. Hypnagogic sensations occur as one enters initial stage 1 sleep. REM sleep is considered paradoxical because it produces waves similar to wakefulness, but the body is at its most relaxed. Dreaming typically occurs in REM sleep. The frequency of REM sleep typically increases as the cycle progresses. When deprived of REM sleep, REM rebound can occur. Finally, memory consolidation and restoration are current theories about why sleep occurs. These theories suggest that sleep is useful for organizing and consolidating memories or restoring depleted resources used throughout a given day. So first, let's define what do we mean by sleep. So it's this periodic natural loss of consciousness, which is distinct from unconsciousness resulting from something like a coma, from general anesthesia, or hibernation. To understand when we sleep, we need to understand this idea of our circadian rhythm. So this is a biological clock, i.e., an internal clock, where it regulates regular bodily rhythms, for example, of temperature or wakefulness, that occur on a 24-hour cycle, approximately 24 hours. So human sleep patterns follow a circadian rhythm corresponding to about 24 and a half to 26-hour daily cycle in the absence of any external time cues, meaning our body would still do this even if we don't have things like clocks or the sun to tell us. It's responsible for varying levels of arousal throughout the course of the day and really is based on this light-dark cycle. So essentially, when the sun is up, it's telling us that we should be awake. When the sun goes down, our circadian rhythm starts to tell us that it's time to go to sleep. This becomes a problem for someone that does shift work, either working really late at night or working overnights. Lots of studies have been done with wide variations in the attitudes of employees towards shift work and their ability to adjust their circadian rhythms and adapt to changes in sleep, eating, and social patterns. So there's some studies that support people do adjust, but there's lots of others that say people who work these late night shifts never really adjust. Another example of a disruption is jet lag. This is a maladjustment of circadian rhythms that results from traveling through several time zones in a short span of time, like if you're flying on a plane. People experience jet lag when our biological clocks don't match up with our external environments. So essentially, our body gets used to living in the time zone that it does. And if we fly across 3, 4, 5, even more time zones, that's going to throw us off and cause this maladjustment of our circadian rhythms. So, retrieval practice question for you. Describe what the circadian rhythm is in your own words. And second, why might working a night shift cause a disruption to someone's circadian rhythm? Go ahead and answer. So hopefully you said circadian rhythm, again, is this biological clock that's based on the light-dark cycle. It's essentially our body telling us that we should be awake when the sun is up and asleep when the sun is down, to put it very simply. And then why might working a night shift cause a disruption? It's because we're not awake. We're awake when we should be asleep and trying to sleep when our body's telling us we should be awake. So next we're going to go to the sleep stages. I highly recommend you go to the weekly agenda and grab the chart. I have filled in some information on that chart for you so that you won't have as much writing to do about each of the sleep stages. You'll see I have some introductory information here first, but just an FYI, make a copy of that chart. It'll make it a little bit less writing for you. So first, to understand the sleep stages, we need to know how do we know what stage someone is in. And to do that, we need to be able to measure our sleep activity. So this is the types of measurements that we take if someone has what's called a sleep study or a polysomnography test. First, we measure brain waves via an EEG. If you remember, that's the test we talked about before. We also measure eye movements. That's what you can see with these measurements here, as well as chin movements to measure our muscle tension. And we'll see that all of these measurements change depending on what cycle of sleep that someone is in. So the sleep stages, along with their differing brain waves, we can see waking beta waves, waking alpha waves. I'll talk about those in just a moment. REM sleep, and then some of our non-REM 1, non-REM 2. Notice that all of these brain waves look just a little bit different, and that tells us what stage someone is in. So during sleep, we normally pass through 4 different stages of sleep, so NREM 1 through 3, as well as REM, i.e. rapid eye movement. Each complete cycle runs about 90 minutes, but it's not a nice straight line, as you'll see on this next slide. So this is how we move through the stages in a typical night's sleep. This one up here is for your age, what we might expect. So we go from awake, we go into NREM 1 for a short period of time, NREM 2 for a little longer period of time, then NREM 3. We'll find out NREM 3 is your really deep sleep. And then notice we stair step up. So NREM 2, then up to REM for a short period of time. Then we drop back down into NREM 2. Okay. Notice, see, that's about 90 minutes or so to move through all of the stages. Okay. Then we go back down into NREM 3, back up to 2, and then a little bit longer in REM. Maybe we wake up for a brief moment. Then we stair step back down, back up, and notice that REM increases as the night progresses, and our deep sleep decreases as the night progresses. Okay. Here's the problem. If you're only getting maybe 4 or 5 hours of sleep a night and not the full 8 or more that you should be getting or need at your age, we're shortchanging ourselves on REM, and we'll talk about why that might be an issue in just a little bit. For older adults, notice that we cycle through these stages a lot more quickly and spend a lot less time in that NREM 3, more periods of wakefulness throughout the night. We get much shorter periods of REM as we age compared to when we're younger. So this is what our brain waves look like when we're alert. This is when you're feeling really awake, eyes open, you're alert. You have beta waves, are the brain waves, what these are called. This is our chin movement. Lots of movement there, even if we're not talking. And then this is alpha waves. This is if you're feeling a little bit sleepy. So if you're doing this late at night and you really want to go to bed, you're doing that whole head bobbing thing, your brain waves more likely look like alpha waves. Okay, you're a little bit drowsy, but still lots of chin movement going on. So now let's talk about these 4 different stages. This is where you'll want to pull that chart out. Notice I filled in some of this information for you, but you want to make sure that you fill in any additional information. You can either, if you've printed the chart, either handwrite it or just type it in. So first, our brain waves are both alpha and theta waves. For our eye movement, you'll see me talk about it at each stage. That's what this chart over here is showing, is more slow and rolling and uncoordinated. That means that each eye is moving independently. The brain stops processing sensory information from our eyes when we first fall asleep. Easily aroused just means it's really easy to wake you up. So if you were to fall asleep in my class and I, tap you on the shoulder or say your name, if you're still in NREM 1, it'll be really easy to wake you up. The myoclonic jerks, if you've ever had that weird twitch, I don't know how else to describe it. It's that weird twitch usually happens right when you're falling asleep that you have no control over. That is a myoclonic jerk, only happens in NREM 1. The other things that happen are hypnagogic sensations. If you've ever had that sensation of falling or you're floating, especially when you're first falling asleep, That often happens in tandem with hallucinations, where you have a false sensory experience. So if you feel like you're running and you fall off a cliff and you can see it, or people talk about being abducted by aliens, there's a good chance that they were in NREM 1 and having this hypnagogic sensation along with a hallucination. Finally, someone might experience what's called retrograde amnesia if we wake them up. That means you don't remember what happened just before you fell asleep. Again, this is our chin movement down here. Next is NREM 2. NREM 2 has just theta waves, as we can see in this image here. Our eye movement stops or slows down significantly. That's what we're seeing in this image. This is kind of an intermediate stage of NREM sleep. Takes up about 20% of our total sleep time, but it's considered non-restorative sleep. This is not the sleep where we wake up feeling necessarily super refreshed, although it can help if we take a little nap and we go into NREM 2, but we're not having any sort of muscle repair happening. This isn't the part of sleep that's helping our memory. We'll see that with a later stage. The other really unique things you want to make sure you make note of for NREM 2 is we get some kind of different brainwaves that happen during this stage. One is called sleep spindles, which are these little bursts of, you can see down here, this little burst of brain activity, as well as K complexes that are precursors to delta waves, which are going to be the brainwaves that we see in deep sleep. Next, we have NREM 3. So we see a pretty significant change in our brainwaves. Notice how these are very long and drawn out. Think delta waves, deep sleep. Okay, so NREM 3 is our deepest sleep. If you went into NREM 3 in my class, I would have a really hard time waking you up. If you've ever missed an alarm, it's likely because you were in NREM 3 sleep. Okay, that's what it means by high arousal threshold. It's really hard to wake you up. Okay, this is also the sleep of musculoskeletal recovery. So those of you that are athletes, you work out, NREM 3 is really important for that muscle repair. It's happening during this stage. This is also the stage where we have a lot of interesting things happen during our sleep. Some dreams happen. We'll see even more of them in REM sleep. Night terrors, we'll be talking about those in our last module, as well as things like sleepwalking and sleep talking, as well as bedwetting, all happen in NREM 3. Finally, take a look. This is our eye movement. There's minimal eye movement, and again, it's uncoordinated, but we do see some chin movement happening. So now we get to the kind of star of the show, REM, i.e. rapid eye movement sleep. This is like a whole different entity in terms of sleep stages. That's why everything else is not REM. Then we get REM. So first, our brain waves look more, look most like beta waves. Beta waves meaning those waves where we're really awake and alert, even though we are asleep. So we'll see them look most like beta waves. What makes REM really unique, why it's called rapid eye movement, is literally we have rapid eye movement. So if you were to watch someone's eyes while they're in REM, you would see them darting all over the place, but they're doing it in a coordinated way. So look at how big these wave patterns are. This is your eyes, and notice they're working in a coordinated manner. So they're mirroring each other in terms of their movement. Our chin movement, if we see down here, is flat. This is due to muscle atonia. So essentially what happens is our brain paralyzes the body while we're in REM. Okay, it paralyzes the body. A message is sent from the brainstem to the motor cortex to ensure we don't move. And one of the reasons for that is most of our dreams happen in REM. And if we did not have this feature where we basically paralyze ourselves, we would be doing some weird things like acting out our dreams. And we don't want that. Okay. This is also the stage where sleep apnea is most common. We'll be talking about that when we talk about sleep disorders in our last one. It's the stage where we have the most dreams and nightmares. This is kind of a weird fact, but sexual arousal happens to pretty much everyone all the time when you're in REM. It's not anything that you can control, and it happens no matter what kind of dreams you're having. Last, as it said in our learning targets, REM is often called paradoxical sleep. This is because our brain is very much almost awake in terms of its activity, but our bodies are paralyzed and we are very much asleep. So, very active brain, very asleep body. Last thing I forgot to mention, this is a time of psychological restoration when we talk later on about why we sleep with memory consolidation. That is happening during REM, which is why it's so important, especially at your age, that you go into REM because it helps you with things like school. And you might notice that if you're not going into REM, i.e., not getting enough sleep, you might find yourself struggling because you can't remember things as effectively. Okay, y'all. I would love for you to give me a 1-sentence summary about each of the sleep stages. So I'm looking for about 4 sentences. If you could label them NREM 1, little summary, NREM 2, little summary, and so forth. And then finally, explain why REM is so much different than NREM stages 1 through 3. All right. One last thing to talk about before we go into 2 more slides about why we sleep. And this is the idea of REM rebound. What tends to happen is if we on the regular are not getting enough sleep, which means, let's say for you all, you're only getting 5 or 6 hours instead of the 8 that you should be getting. What's really happening is you're shortchanging yourself on REM sleep. Then when you get to things like weekends or breaks over summer, where you are able to get your full 8+ hours of sleep a night, you might find yourself going into REM cycles more frequently. Think of REM rebound as your body trying to kind of like catch up on the REM cycles that it missed out on. So last, just 2 more slides about why do we sleep? What is the purpose of us spending this much of our time? So first, sleep restores. So while we sleep, it gives our body and brain the chance to repair itself, to rewire, and to reorganize. It also helps the body heal from things like infection and restores the immune system. That's why you find yourself sleeping so much when you're not feeling well. Sleeping also gives time for neurons to repair themselves. This would be the time where our brain really cuts back on any unused connections. That process is called pruning. So restores our entire body, our brain, everything, our immune system, etc. And the second reason is for memory consolidation. So it helps us restore and rebuild fading memories from the day. So it strengthens and stabilizes neural memory traces. And we have evidence of this, of our memory essentially strengthening as we sleep, because they've done studies where they've taught people tasks before going to sleep. So they learn a task, then they have them sleep, and then they see their performance on the task afterwards. And they compare that to having someone learn a task, stay awake for the same period of time that someone slept, and then ask them to do the task again. And we know the people that slept were better able to do the task or remember what it was that they were asked to remember. We also know that our neural activity during sleep reenacts and promotes recall of prior novel experiences, like interesting things that happened. So, really great. How can you use this to your advantage in terms of studying? If you study, not when you're drowsy, like half falling asleep, but if you study like an hour or so and then go to bed, a little bit later, you're going to be more likely to remember what you studied just before going to sleep, as long as you weren't in a super drowsy state when you were trying to study. Okay, y'all. Last question. Explain 2 of the main theories about why we sleep. Once you do that, you are done. We will talk about this in class. Thanks all.